Hello, my name is Brooke Bates, and I'm the president of the Consumer Product Manufacturing Enterprise at Michigan Tech. The CPM Enterprise is one of 25 enterprise teams here on campus. Our enterprise aspires to empower students with entrepreneurial, technical, and professional skills to conceive, develop, and market successful products in a company-like setting. Students on the team come from many disciplines and use hands-on experiences to identify and solve real-world engineering problems. CPM aims to exceed the expectations of company sponsors, improve the lives of consumers through innovation, and develop our team members into highly marketable professionals. Here are a few of the companies we have been fortunate to work with.
Hello, my name is Cole Sturm. CPM currently has 10 internal and industrial sponsored projects centered around 3 main categories. The categories are biomedical advancements, sustainability, and product commercialization. Today, we'll be highlighting one project from each category in CPM. The projects are clean diesel, AAA, and commercial kite cleaner.
Hello, my name is Brady Good, and I'll be discussing the clean diesel project. The problem that the team has identified was that Michigan Tech's dining halls produce roughly 120 gallons of waste soybean oil per week, while simultaneously the university's grounds crew consumes thousands of gallons of diesel fuel per year. The team's objective is to create biodiesel using waste soybean oil. The impact of this project includes reducing emissions on campus and furthering Tech's pursuit in sustainability. On the right are figures 1 and 2, displaying clean soybean oil and a biodiesel gas station option. To accomplish this goal, the team has developed a process that uses simple equipment to undergo a trans-esterification reaction to convert the soybean oil to biodiesel. Shown in figure 3 is an outline of the current production process. Some of the notable results of this semester include the finalization of the procedure, determination of variables to optimize yield, a completed simulation of the plant in unison, and the creation of a cold filtration trial plan. Shown in figure 4 is the separation process. Here, the less dense biodiesel product floats atop a glycerol byproduct layer in a separatory funnel. Pictured in figure 5 is the team's successful test run of pure biodiesel in campus equipment. Shown within table 1 is the cost analysis performed on the process. With current operations, the university spends roughly $33,000 annually on fuel. If the university switched to pure biodiesel or B100 operations, the university could potentially save just under $17,000 per year. However, due to climate conditions and engine limitations, a 20% biodiesel, 80% petroleum blend may be preferred, and this would result in a savings of around $4,000 annually. Next steps for the project include scaling up the current plant, conducting a second engine test, and sending out product samples for quality testing.
Hello, my name is Danny Martin, and I will be covering the Affordable, Authentic, and Accessible Prosthesis project within consumer product manufacturing. The goal of AAA Prosthesis is to develop, test, and bring to market a mechanically passive lower limb prosthesis that allows for an affordable cost without losing the durability and functionality. The impact of this project is to create an affordable option for lower limb amputees that allow for them to regain their ability to walk, regardless of their insurance coverage. Figure 6 shows an aluminum prototype of the foot component, while figure 7 shows the stilt used for testing of the ankle component. AAA Prosthesis intends for the mechanically passive solution to allow for low cost of manufacturing, highly functionality, ease of maintenance, all while keeping the industry standard of efficiency and durability. Figure 8 is a diagram of the ankle's design, allowing for inversion and eversion, while figure 9 is a 3D printed prototype of our foot component. In table 2, we see a cost comparison among various prostheses in the market. AAA is around $150 to $200 based off of current manufacturing processes, while the OSAR Pro Flex Cat 5 is around $900, the Ability Dynamics Rush Rampage Cat 3 is $550, and Freedom Innovations Highlander is $599. All of these prostheses are lower limb, ankle, and foot prosthetics that have around the same functionality. The next steps of the AAA Prosthesis project is to continue the gait analysis using the stilt, begin cyclic and load testing of the foot component, and analyze all of the data from these two tests. Figure 9 is an image of the universal testing machine, while Figure 10 is a participant testing AAA's ankle using the stilt manufactured.
Hello, my name is James Staley, and today I will be talking about the commercially viable keg cleaning device. The goal of this project is to develop a cost-effective, semi-autonomous keg cleaning device that is designed to be an open-source document and helps remove the economic and safety barriers that small breweries face. The impacts of this product will once again cut the cost of brewers, as well as delivering a keg that is clean to regulatory standards, as well as limiting the exposure to workers to caustic chemicals and acids. Figure 11 shows the completed prototype developed by CPM. The solution that the CKC team came up with was that they developed a fully functioning prototype that is designed around a standard 3-basin sink and fitted that prototype with a programmable logic controller, or PLC for short. This PLC controller is automated as well as has manual options for opening and closing valves. The team also produced build manuals that detailed how to build the unit, and included in that is plumbing and electrical layouts. The team also began testing and troubleshooting in ChemSci S001 lab. Figure 12 shows the PLC control screen, where the brewer can manually open or close valves, or put the system into automatic and let the system run its cycle. Figure 13 shows an image from inside the keg while the unit is in operation. What the team came up with for Table 3 is a price comparison. The team is offering a device at $2,700 compared to other options on the market. One of those being the Gladiator, which is about $14,000, or the Noble Keg Washer for $5,500. Also in this table includes the speed at which the device washes the keg, as well as the maintenance required for each unit. Figure 14, the blue line, shows that the recycle feature that is included within the CKC's prototype, of which is far less than the red line, which includes no recycle on other units. The next steps for the CKC team will be to test the prototype at the Q&L Brewing Company, test our build manuals to ensure the steps are easy to follow, and release a manual for open source and documentation. Figure 15 shows testing being completed at the KBC.
Please contact the CPM Enterprise at mtu.edu email or visit our website, cpmenterprise.org, with any questions. Thank you.